Let me help you. Admittedly, you look at it, and because there's these square root things, by the way, writing it as things to the power of a half, I think, yes, I'm totally in on this. And that doesn't really help at all. Okay, so what do? First, let's take first principles, and let's see what it equals in this case. Okay, so you start with the limit. Okay. By the way, people don't usually start with the limit and then forget to put it on, or stop putting it on. They usually forget at the beginning. Okay, so that's why I'm always going to say, and I hope you say in your own head, start with the limit. Okay. What's f of x plus h? It's just the square root of x plus h, right? Okay, and then you've got minus f of x, which is that, and that's all divided by h. Now remember, your goal is to get rid of this h, okay, but get it out of the denominator somehow. Now before, what we did was we expanded. It was quite simple what we had to do, okay? But in other words, we manipulated the numerator so that the h appeared in common, okay? So we had to do something with this guy in order to get rid of this guy. Okay? Now, you've got square roots, okay? Square roots are notorious for being hard to work with. They don't interact with each other, right? So I have to change them into a form that will allow them to do that, to interact. And there's one way which you've learnt in Year 9, namely what we call the conjugate, right? Conjugates are useful because they allow us to take advantage of difference of squares. Come in. Okay.
May I just have Richard for a moment?
Okay, now that I've got my conjugates there, what does it mean? I've got difference of squares up here, right? So, just in case you can't quite see it, it's a minus b, a plus b. Yes? So when I factorize that, it should be a squared minus b squared, right? But because everything's square roots, start with your limit, it'll be a squared minus b squared, okay? Now, this conjugate, unfortunately, doesn't do anything to the denominator. So this is kind of backwards what we're used to doing. We're used to, rationalizing the denominator. I'm kind of irrationalizing the denominator, but it's actually what I want. Because now, I can work with the numerator. These x's, just like over here, they cancel, right? That x and that x. So I've got the limit as h approaches 0 of, and these h's here, which are in common, cancel out. Now you might look at that and think, this is no better than where I started, right? I've still got these square roots flying around. Well actually, it's much better than where we started because we got rid of that h on the denominator, which was the problem. I can actually put in h equals 0 at this point. Okay, so when h is 0, I've got 1 over the square root of x plus the square root of x. That's 1 over 2 root x. Now, I'd be usually happy with that, except I just want to draw out the fact that if I wrote this in index form, it'd be half x to the power of a negative, because it's on the bottom, and it's a square root, which is exactly what we're expecting. Okay? So this rule here, this is nx to the n minus 1. It works regardless of what number you've got as n. It can be a whole number or it can be a fraction. Okay?